Hello, welcome. Today we're going to be looking at some basic concepts in radiation or radioactive decay of substances. We're going to be looking at half-life and decay constants. What is half-life? The half-life of a radioactive element is defined as the time taken for the atom of a radioactive element to decay to half the original number. So that time for the atoms of a radioactive element to decay, that time it takes them to decay to half of the original number is known as half-life. So let's say that the atoms of a given radioactive element, radium, is 300. The time it takes for that very radium to get to the number of atoms 150 is the half-life. So the time it takes to half the original number of atoms in that particular element is known as the half-life. Now, let's look at what radioactive decay is. Radioactive decay is simply the process by which a heavy radioactive element disintegrates and emits uh, substances like X-ray. So the process by which a heavy radioactive element disintegrates into smaller one, emitting things like alpha, beta, gamma, or X-ray, is what we call radioactive decay. So it's very, very important that you take note of this. Half-life is simply the time taken for the atoms of a radioactive element to decay to half of its original number, whereas radioactive decay is simply the process by which the heavy radioactive element disintegrates into smaller elements, emitting alpha, beta, gamma rays, or all these sorts of rays that we are going to be studying in subsequent classes. Now, let's look at other things like binding energy, mass defect, and atomic energy. Now, what is binding energy or mass defect? Mass defect is the mass of the element lost when a given mass of a radioactive atom is split into two parts. So mass defect is actually the mass that is lost to produce emissions like gamma rays, X-rays, and all that. Because when a given mass of a radioactive atom splits into two parts, the combination of the two parts does not equal the original one due to mass defect. Now, atomic energy is the energy released as a result of splitting of a radioactive nucleus by fission or fusion. So whenever they are splitting, that energy that is released is known as atomic energy. Now, binding energy is the amount of energy required to separate completely the protons and the neutrons in the nucleus. So that energy required to separate the protons from the neutrons in the nucleus is known as binding energy. According to Einstein, the difference in mass of all the individual nucleons and mass of nucleus is a measure of the binding energy. Now, what are these rays that we are talking about? The alpha, beta, and gamma rays. Alpha ray An alpha particle produces thick trace of straight lines or straight rays. The straightness is because the particles are heavy and are not easily deflected by collision. Whereas a beta particle produces a thin wavy trace which are light and easily deflected when they collide with other molecules. So that of beta is lighter, so it can easily be deflected. Whereas gamma ray produce faint rays caused by a knockoff of electrons. Faint rays. So this is actually rays, thick rays, wavy rays, faint rays. No single radioactive source can emit all the three types of radiation at the same time. Only one or two types of the above radiation is emitted by a particular radioactive source. So that is where we're going to be stopping: alpha, beta, and gamma rays. So if the emission is thick, we call it alpha ray. If it is wavy and light, we call it beta ray. But if it is faint and is actually by electrons, we call it gamma rays. In subsequent classes, I'm going to be giving us the formula for half-life, as well as formula for a given alpha particle, beta particle, and gamma particle. Please, if you like this video, hit the subscribe button. If you have any questions, drop it on the comment section. If you want to contact us and help us, please check the description section. Thank you and God bless you. Please subscribe. Thank you.